This podcast is sponsored by AppDynamics. Software architects play a critical role in designing, executing, and migrating large infrastructures to the cloud. Download AppDynamics' free ebook, 10 Tips for Enterprise Cloud Migration, and launch your migration project with a proven plan. Download the ebook now at infoq.link/appdynamics.
Hello and welcome to the InfoQ podcast. My name is Wes Rice, and in addition to hosting the InfoQ podcast, I chair a set of software conferences called QCon. If you're an architect, developer, or technical engineering manager, check us out. You'll love it, I promise. This week's podcast was recorded live on site at Strange Loop 2017. In it, I'm talking to Charity Majors. Charity is the co-founder and CEO of Honeycomb.io. This is a startup that's been getting a lot of mentions in the observability, instrumentation, and monitoring space. On this podcast, we talk more about Honeycomb, what problems they're trying to solve and why. We talk a bit about the social side of debugging that they're trying to work through. Then we talk about her talk that she did at Strange Loop this year that was called Observability for the Emerging Infrastructure. What got you here won't get you there. You can find that video and all of the other videos from Strange Loop online on their YouTube channel. This podcast, Charity hits on things like advice for testing and production, including canaries and dog fooding clusters. She talks about shadowing and splitting traffic. She discusses things like sampling and aggregation when you're grabbing events for metrics. It's a great podcast. Hope you enjoy it. Thanks for listening. We're here with Charity. Charity, welcome to the InfoQ podcast.
Thank you. It's nice to be here.
So you just literally got off a plane from Ireland, gave an awesome speech. I was there, talked. It was fantastic. How you feeling?
A little bit, that crash.
That adrenaline rush.
Adrenaline, yes, and then you just start replaying all the things that you wish you had said or said differently. But so this is a nice distraction.
So we have a new pattern. It's not a distraction, it's a new pattern. You can talk about all the things you wish you had said. People can watch the talk and go, here's what I missed.
There we go. That's a good idea.
So you are the CEO and co-founder of a startup.
Yeah.
Honeycomb. Could you tell us about Honeycomb?
Yeah, Honeycomb.io. It's we're about a year and a half old. We started on January 1st of 2016, which is crazy. And for the first, we had to start by writing a storage engine, which takes a while. So we've had customers for a little over a year, but it's really only in the last 5 or 6 months that we have become a thing that I feel like I can tell people that they should use, and not just as a favor to me because they're my friends, you know. But what we do, we are trying to help people understand the world of very complex systems. And this was born out of my experience at Parse. My co-founder, Christine Yen, was at Parse too. And we were old school Parse through the Facebook acquisition. And around the time that we got acquired by Facebook, we were hosting about 60,000 mobile apps, and we had built a system that was effectively undebuggable, by many of the best engineers in the world. And it wasn't that we had built anything poorly. We had built a great, internal graphite, ganglia, all the best that open source had to offer. Metrics, dashboards out the ass. It was instrumented as well as we could, but a few times a week, we'd have the experience of a user coming and saying, Parse is down, or there's some problem. And I would dispatch an engineer, or I would go and start debugging, and it would take hours, days, sometimes weeks to find some of these long-tail problems. And, we get acquired by Facebook and started using Scuba, and it changed my life, like the Facebook Scuba tool, because we were able to cut the debugging time down from days to, seconds, sometimes minutes, just reliably.
So how did Scuba do that?
So Scuba is it's an in-memory system that takes your raw events, and there's a columnar store that it uses and just lets you explore. So you're not jumping to a dashboard where it's like, here's a result. It's like, you start with a question, then you iterate, what if I had this? Oh, what about this? Because so many of these problems they're hard to debug because it's about something that happens very rarely, intersecting with something else that happens rarely, or it takes a combination of, this iOS version and this device and in this availability zone and this database shard and for this, and so a lot of times what you're doing is you're looking for all of these complaints that I'm getting, what do they have in common? And it has to be an open-ended way of asking these questions. And if you ask engineers who've worked at Facebook what they thought of Scuba, they get all misty-eyed, which is amazing because if you saw it, it's a piece of shit. Like, it is gross, it is janky. Forget opinionated defaults. It doesn't even have defaults. It's terrible. People pass around text pads of useful links that they have, constructed at one point in time. But if you invest the time to get good at it, like, you become a 10x engineer.
That's awesome. So the things that you're doing at Honeycomb.io, is it based on some of the things that you learned specifically with Scuba?
Very much so. In fact, the first 6 months or so, we were really just like, okay, let's build something that looks a lot like what we remembered. And after that, it was like, okay, now let's build something that people will want to use, by looking at it. So the other part of the equation that I didn't actually talk about at all here, because this was not a sales pitch, right? It was very back-endy, engineering specific, but that's not actually going to be what makes us succeed at Honeycomb, having the best back-end. Like, I've been in infrastructure too long to think that. I think that what's going to make us succeed is our ability to bring teams up to the level of the best debugger in every situation, to make it so that, I hate to even say this, but almost like the social network for debugging, for sharing.
Okay.
But so think about your bash history. You have this record of all these commands that you run, and you want access to them because you do the same things repeatedly. And you also kind of want to see everyone else's bash history because the guy who's a wizard at MySQL does shit in the command line, and you're trying to keep, we need the ability to have access to the things that we've done before. So we've built all this history into Honeycomb, and also your team's history. The stuff we're working on right now is making it accessible. Like, if I'm on call and I get paged about Cassandra, and I can either wake Christine up if I know she knows about it, or I can be like, Christine knows a lot about Cassandra, and last time she was on call, something sort of like this happened.
Right.
Let me go pull Christine's history and see.
It's that tribal knowledge, yeah.
Exactly. It's encapsulating the tribal knowledge in a way that makes it, accessible and shareable. And, whatever comments Christine left to herself in Slack, or like put in her own little shared, list of links, or, just opening that up, because I've been that debugger of last resort so many times, and it's fun the first time, After that, I was on my honeymoon getting called, I'm literally on the beach, and Parse is like, we're so sorry, but it's been down for an hour, and we don't know how it's going to get back up. If they just had access to, like, my normal, like, debugging strategies, we have to get better at this.
So how? I mean, when I code, I have a developer journal that I track the things that I do, any special little tips and tricks that I need to find 6 months from now, and I started using Slack for that, so that way I can tag things, and Jessica Kerr kind of turned me on to doing that. But so how do you do that? How do you expose that in a social networking kind of way of my bash history?
Totally.
And particularly distributed, right, across many different instances when you may be bouncing around.
Oh, so it's very much like this, the example you listed with Slack, right? So for example, it's really meaningful whenever somebody pastes a graph into Slack along with the comment. They'll often just like type in something like, latency seems elevated on, the web or something, click to Slack. And then other people can click on that and join them, right? And can see all of the graphs that they've, as they've been asking questions, they see the graphs that you've been tinkering on. And if I'm looking back through and I see something like, oh, this is interesting, I might just click on it and yoink it, run it myself, and append it to my own. We're thinking of them like Spotify playlists almost, more than dashboards, but like, because a dashboard is a place that you stop, right? It's your solution. We think of these as, I've pulled this and yoinked it to my own personal list, but I then click on it and I play with it. It's a starting point. It's not a stopping point.
Are you exposing them through things like Slack, or how do you get to these?
So you can go to the honeycomb.io console, right?
Right.
And as it is now, it's like you can see what your team has been running or what questions they've been asking recently.
Okay.
We're moving towards things like heat maps. Like I almost see it as like an emergent production run book.
Yeah.
Nobody can really document how they use their systems because of that gap between doing and writing it down. But like, if your system is actually, if you look at Honeycomb and is telling you what questions people are clustering around, what are they asking, what data sets they're really interacting with. We're in the early days, but I really believe that something like this, making it very determinedly simple and accessible, and letting you tease, like, all this value that you're pulling the data out of the systems, and that in and of itself is just noise. It's a lot of noise. It becomes valuable when someone has looked at it and interpreted it, and left some sort of comment or share or note or put it in a playlist, something that indicates, or a highlight or a star or anything, something that indicates this was meaningful to me in this context. Yeah. And the longer, like we have an entirely separate dog fooding cluster, Honeycomb. It's all we use to debug our own systems. And it becomes more meaningful the longer you interact with it, which is great, because I'm sure you've had this experience of joining a team that's been around for a while and feeling like you can never catch up. Like there's so much implicit knowledge.
Tribal knowledge.
And like intuition that you can't even really unpack or explain, but it's there.
While new features are getting added, you still got to catch up, yeah.
Yeah, and like frankly, that's demoralizing. It's disheartening. It's hard on the younger folks, the newer folks. It's hard on the older folks for different reasons. But it also is just kind of, it's a smell that the systems are not, you can't reason about them. You can't explore them. And that's been our lives. So people have not realized that there can be a different way. But like the teams that I have been on, which is now 2 at Honeycomb and at Facebook, they are not like that. You can get up to speed and you can become one of the most powerful debuggers like pretty quickly.
So we've been talking about like the social side, the social aspect of it. What about the actual observability side? Is this an agent that runs on each of these instances? Does it listen to traffic? How do you acquire the events or the data?
The short answer is like we don't care. We just take structured data, like key value events, as many key value pairs as you want, some mature structure with the right key, and you can just send that directly to our API. We have SDKs that you can use for like JavaScript, Ruby, Python, Go, and if you want, you can just run an agent that tails any structured log that is being written at disk, or like for your Apache logs, you can use the agent to translate from unstructured strings to structured data and ship it off. But it just has to be structured when it hits our API.
So as we were talking before, you mentioned like a lot of people are at this current state and they want to get to this other state. What is that other state? What is this unicorn?
So the first thing I would say is, if you don't have a big distributed system, you don't need this. If your existing stuff is working for you, great. You should choose boring technology for your monitoring especially, right? And it's just that there are more and more people who are, earlier and earlier on in their development. They don't have to be Facebook before they have that kind of problem. If they're using microservices and they have half a dozen different databases, the hardest part can be figuring out where the problem is. Everything's totally interrelated, and one node can infect a whole bunch of other graphs. If you have that category of problem, then the number of engineering hours that you're dedicating to just trying to locate the problem goes up and up.
So the smell is you start seeing this kind of engineering hours start going up. Your elk stack's not doing it enough.
Yeah,
that kind of thing.
It's a long time to figure. Yeah, it just gets harder and harder to debug these complex systems. And in that case, you kind of have to bite the bullet and go, okay, this is a new category of problems. And if you're having that, so that there are really 2 different solutions or categories of things that are sort of on the horizon. One of them is distributed tracing, and one of them is Honeycomb. And distributed tracing is very much depth first. You pick something you want to trace, and it shows you everything. Now, the hard thing about that is often the exact same problem. What do I trace? And this is not a nut that they have cracked. That is the thing that Honeycomb does exceptionally well. We tell you where the problem is and what to trace. And at some point in the future, there's going to be merge.
But how? So when you talk about distributed tracing, you've got this event or this transaction that comes through the system. You establish an ID. You can trace it all the way through. So what does Honeycomb do different than that?
So you do have to instrument your code some. You're going to want to wrap every call out to another service, wrap it in a timing loop and just stash it in a header or something. Honestly, if you just wrap all the timing information from a service calling out to other services and other databases and put them in headers, this is actually the best thing to do when you're starting to investigate this stuff, because that percolates up to the edge. If you're running Nginx or HA proxy, you can report all that timing information through your entire stack right there. And you can always, just like in a couple clicks, find the component that is having a problem, whether it's a node or a container or a database or a cluster or, it doesn't even matter. It's just, it's amazing. It's transformative. But so there are a couple of ways that what we're doing is very different. We deal with raw requests. We do not deal with aggregation. We do read time aggregation for display purposes, but not write time aggregation. So you can always get back to that source of truth. Finding problems is often just like finding needles in haystacks, and you have to be able to identify the needle by any number of ways.
So you have a tweet that's pinned when I was doing some research. It says, monitoring is for operating systems software. Instrumentation is for writing software. Observability is for understanding systems.
Yeah, exactly.
Explain that.
There's been this real push in the industry, like monitoring is for everyone, it's not just for ops. And I understand why they've done it. It's because it needs to be everyone's responsibility. And it does. But monitoring is fundamentally an act of operating software. It's
A responsible operating software.
Yes, well, fair enough. It's very problem-oriented, though. It's very it leans towards caring about failures. Like, everyone should do ops, even software engineers.
Where do you draw the line? I mean, like you mentioned before that you should just instrument everywhere. You should just emit events for everything. Mm-hmm. Where do you draw the line?
Where you have to, for lack of, I think that monitoring is clearly for operating your systems and services because it's about looking for predicted results and making sure that your system is still within bounds, It's about your known unknowns. It's about, in every postmortem, we have this process of, oh, hey, we found this thing through long and painful debugging. Now it's a known unknown. Now we can monitor for it, And sometimes this includes instrumenting your code. Sometimes it doesn't. That's the difference between black box and white box monitoring. But it's all fundamentally about, from the operator's perspective, what are you doing? And instrumentation is kind of, the flip side. It's from the development perspective. How am I going to understand and monitor this once I have problems? And monitoring for a long time used to be very much about, the predictable results. But you need to instrument in a slightly different way in order to take advantage of these very open-ended questions. It's a much more explorable. It's much more, you're going to want to wrap every meaningful incident of something that happens in your code so that you can go and ask these ad hoc exploratory questions later. And observability, the main way that it differs from, I like to say that it's a superset of monitoring, but one of the main ways that it differs is that it's not just about problems. It's about understanding it. Sometimes this is for business purposes. Sometimes this is for, you're just trying to figure out if that thing that you shipped did what you think it did, I think that the reflex of, I shipped a feature, I shipped a thing, I'm going to go look at it in production, I really feel like that should be ingrained in us and embedded in us. It's insane that we write code, run our tests, and don't look at it. And I feel like that's just because we haven't had the ability to do it, because the best engineers I ever worked with at Facebook, I would see them spend half their time in their IDE writing code and half their time in Scuba just understanding it.
Yeah, you said something in the talk that I liked. It said good engineers observe their system or watch their system when it's working the way it's supposed to be, so that way you know what it looks like when it's not. I thought that was pretty cool.
Yeah, so many people don't even know what normal looks like, so they definitely don't know what abnormal looks like. And this freaks out a lot of software engineers when they start looking because they don't realize how many things are going wrong all the time. There are errors happening all the time for various reasons. And a lot of people are like, and they want to spend all their time chasing them down. It's like, you know what? This is just the way software is.
High cardinality. You mentioned that a lot in your talk.
Yeah.
Define that.
So high cardinality is for example, if you have 10 million user IDs. Every single one of them is different. That's very high cardinality. And existing metrics and dashboard systems just do not handle that at all. And so there are all these hacks that people have done around it, which are sad because many categories of things become just massively trivial once you can handle those. So it is also one of those things that I feel like lots of people don't really understand what it is, or they haven't internalized how much easier their lives would be if they had it, because they've never experienced it. Most engineers out there in the wild have never experienced the ability to break down by a high cardinality field, and it is transformative.
So why? What does it give you?
Well, for example, if you're a platform and a user writes in and says, parses down, for example, you'll start jumping around between logs, looking for their user ID and dashboards. What you can't do without high cardinality fields is just break down literally by, first show me for this app ID, now show me everything else. Say that we have 100,000 requests per second and they're doing 8 requests per second. In those time series aggregates, it's literally never even going to show up every time they hit the login endpoint.
It's different ways of looking at things.
Yeah, from the perspective of the user or the shopping cart, or breaking down by everyone with the last name of Smith. There are just all these things that you can't slice and dice by the most meaningful things in your data set.
Yeah, makes total sense. So I want to go back to the high cardinality for a second. So I know what it looks like to go to Log4j and log something, right? So I'm just kicking out a log. How do I write that, or how do I instrument things in a way to give me that high cardinality? Is it something after I'm emitting it that I then process it?
It's about your data set. So you're going to want to capture, anywhere you can, in every context you can, capture that user ID that it relates to, or that group ID, or that, any shopping
ID,
any coordination ID, any IDs you have access to should be emitted wherever you're emitting anything, because it's that act of slicing and dicing, and you have to have that information available to you.
So the cardinality comes from the fact of where this user ID, this correlation ID, is being seen throughout the system.
No,
it's not that you're emitting
It's the nature of the user IDs themselves. Yeah. So like a collection of all last names is going to have slightly lower cardinality than all unique UUIDs, right? But it'll still be much higher than, say, process IDs, of which there can only be like 10,000, right?
Right.
It's the nature of the data itself there that makes it so useful for finding unique rare events.
I wanted to talk about your talk just a bit. The talk, again, it was at Strange Loop, and it was observability for the emerging infrastructure. What got you here won't get you there. Yeah. Why that topic?
Because I think that we've built up this really rich set of best practices and approaches to understanding our systems that have worked incredibly well. And if you look at all the great tools that were built during the LampStack era, Splunk, New Relic, I am in no way trying to say that they are bad or wrong. They're amazing, but they're great at known unknowns. And even they will admit it, They're really good at answering known problems really fast. They are not good at, okay, I have a couple of weird reports. What the hell is going on?
Right.
And if you start with the assumption that you know the question, you're not going to find the right answer, because it's almost like the answer is easy, but the question is hard.
Exactly, yeah.
And Honeycomb is very much about, okay, what actually is the question?
Yeah.
And it sounds kind of terrifying and uncharted, and just like you'd be lost when you start swimming in all this data. But it's actually not as hard or as open-ended as it might sound. In my experience, you generally want to start at the edge and work your way down. Or if you already know it's a data problem, you start at the bottom and work your way up.
Okay.
So for example, latency is rising across the board. What do? Well, you start at the edge. You break down by endpoint, or by error rates, to say there's no errors. So you break down by endpoint and you order. Okay, so the slow ones, seem like there's 4 or 5 slow ones, and they all seem to be right endpoints. Okay, so let's start breaking down for those endpoints only by the data source that they're writing to. And I see, it's only the ones that are writing to MySQL. Well, is it all MySQL, or is it just some of them? Okay, it seems to be just primaries that are in this availability zone. It's just kind of that iterative, you just follow the breadcrumbs, and you can't say exactly where you're going to go. But if you started out by just scanning dashboards, you'd have to look through a ton of dashboards to find that.
Yeah, absolutely. Yeah, and they might all be green.
Yeah, they might all be green.
As you said in your talk.
Exactly.
Yeah. So in this talk about an electrical grid as a reference. Why that analogy?
Because I was having a hard time. I wrote an article called Test in Production, and some people were like yelling at me that it was wrong. And I found that even if I said, well, you can't clone Facebook, they'd start pushing back on me. Yes, you can. You can have a staging copy of Facebook. And I'm just like, oh, what about the electrical grid? Like there is a point you have to, everyone has to agree that at some point it becomes not economically feasible or practical or even desirable to try and, flesh out all of these problems in a staging environment. Staging environments have their own categories of problems.
Right.
It drifts away from production. It's really hard to maintain. There's no replacement for the unique combination of this deploy, this code, this release, on production.
This day of the week.
Yeah.
There was something you said in the talk. Everybody laughed. I think it was try building the electrical grid in stage. I thought that was great.
Yeah, I feel like we only have so much engineering time. We have a scarce amount of engineering cycles, and the more time that we invest, like fooling ourselves into thinking that we should have confidence in this release and staging, we're starving our production systems of that time spent hardening it, spent making it resilient, spent investing into our deploy tooling. I don't know of any company out there who, well, that might be a slight exaggeration, but not much, who has invested adequately into their tooling around, canaries, like partial releases, run multiple versions at the same time without confusing everybody.
Yeah.
But that's actually what you have to do at scale.
Right. You talked about some tips with canaries also in the talk. What are some of the practices, tools, tips that you have around testing and production?
like with so many other pieces of advice, this is highly contextual. It's a total waste of time until it isn't. But once it isn't, you can't live without it. For one, anytime you have the ability to deploy to a version that you yourselves are running in-house first, oh my God, do it. Like Slack can do it, we can do it, Facebook can do it, and you'll always notice because you all are using it all the time, right? And yet your users don't have to see it. Automated checks on canaries are amazing. Say you roll out to 1%, and then you have a bunch of basic health checks that are just like, okay, does this look basically the same? And then automatically rolls back and like notifies a human. Those are so amazing if you have a lot of interns.
RPS are the same. Those kind of things, are they're lower.
Exactly. Yeah. They're table stakes, and yet most of us don't have them. It forces you to follow a lot of good data practices, like versioning your schemas, but having the database run fine with multiple versions, both before and after the upgrade, like concurrently.
All right, I don't want to say canaries is the obvious one, but it's more obvious than others. What are some of the other techniques that you might recommend for testing in production?
Here's one of my favorites. I really like the practice that some companies have of having a load test running all the time. 20%.
Yeah, I think I saw it. I think I saw either a tweet or a screenshot of you.
It's so insane.
Yeah,
but
what's up with that?
It's nice because then you always know that you have headroom. Always.
You can just turn it off, right?
You can just turn it off. And it tells you, it's just a nice buffer to have. So, but most people aren't going to do that. And honestly, I'm not brave enough to test in production most of the time for load tests.
By the way, I should qualify. You made a point in the talk also of saying this doesn't mean I'm saying don't test before you get to production.
Definitely test before production too. Yeah. And I think that the meme about, I don't always test, but when I do, I test in production. There's an implicit only in that meme, right? That is not, we do not actually recommend that. I really think that everyone who has access to master should know how to deploy and how to roll back. I think that a reasonable time for deploying is about 5 minutes start to finish, and that includes rolling. If you're deployed, and another piece of advice that I don't remember who originally said it was make sure that the easiest, fastest path is always the default one. You don't want the rollback to take some weird thing that's faster that you don't usually do, like it should always be. It's worth really paying attention to that. The more time that consumes, and as it drifts towards half an hour to get a deploy out, you've lost your ability to move with confidence.
Yeah.
Oh, one other. Splitters and shadowing.
Oh, okay.
Yeah, this is so at Parse we actually had to do a whole API rewrite from Ruby to Go because it's not that they were wrong to choose Ruby in the first place, because most startups fail, and it let us move really fast in the early days.
Exactly. It's evolution, right? It's at this point in an evolutionary arc.
So we wrote it in Ruby, and the main problem was there's one thread per request at all times, and you have a pool of, hundreds of thousands, but they can all fill up in 5 seconds if one of the storage backends gets slow. And it was just making us too fragile. And so we decided to do the rewrite. And we did it endpoint by endpoint.
And you said in Go, right?
In Go. And it was painful because, statically typed and everything. And mobile apps expect so many things that they don't tell you they're going to expect. And you can't change the mobile app because it's in the App Store. So we could not break anything without breaking people's apps. So we used Scuba. And basically, we had a shadow node of the API that was running the new code, and it would fork every request, and it would return to the user the one that went through the Ruby code path. So it'd split the traffic and return the real result to the user and throw away the one that went through our test code. But it would allow us to compare the responses.
Yeah.
And then we could go back and find all the places in our code that we had not explicitly set something to what the user was expecting. And that is the most paranoid form of testing in production, but there's sometimes you just have to do this.
Yeah, I've heard a few stories about people who have some high scale. One in particular was Netflix. When they redid their download feature, they had to adjust how they were doing licensing so that they could, validate that it was an approved download. And they used Shadow Cluster, Shadow Node to be able to split the traffic and validate that they could handle the load and they didn't see any issues with it. So they tested in production.
Totally. And feature flags, another great thing for testing in production.
Yeah. So you talked about aggregation versus sample.
Yes.
Talk a bit about why you prefer one or the other.
Yeah, totally. So the reason that metrics and aggregation have been so popular is because they're very cheap. And they are great at that. Their metrics are very performant, and they're all very cheap to store. It goes back to the original RRDs, right? Just keep compressing that stuff as it rolls off. The problem is you lose so much context, and you can never get it back. Like once you've smushed everything that happened in that interval to just, one number, you can never get that original request back, so you can never see what actually the user was experiencing. And when our priority was the health of the system, that was fine. But increasingly, our priority has to be the health of every single request, every single user, blah, blah, blah.
The whole experience.
The whole experience. And you need to be able to trace that entire request all the way through the stack. Now, obviously, we can't pay to store, 200 times as many. I was saying in the talk that, you'll generate hundreds of events through the stack for every API request or every www request. And nobody wants to pay for a logging system that is 200 times the size of their production system. You can't. So the trade-off that people implicitly make is they don't capture all this data as it makes its way through the stack. That's not great either, because sometimes you just have to have it. So the responsible, grown-up way to do this is with sampling. And sampling kind of has, people assume that it's just 1 in 10, just, you throw away the other 9. But sampling does not have to be that blunt. Dynamic sampling is what we do at Honeycomb, and it's the sample rate is just in a key value pair in every event. So it gets drawn correctly when you're looking at it in the UI. But it lets you say things like, okay, for all of my database read queries for this type that's known to be pretty slow, just keep 1 in 100. That's fine. For every delete, at Parse, we wanted to know whenever anyone had deleted an app, just keep all of those, never throw them away. For web traffic, 200s, you don't need all of those. 500s, you probably do.
So how do you tweak these and tune these as you go along?
Yeah, so I feel like the way that we used to tweak and tune our paging alerts, in a world where we can page ourselves a lot less, but we're doing a lot more instrumentation, I think that this is going to be the thing that people are used to tweaking, on a weekly basis. Just, this thing, I'm getting problem reports about this type of request on this endpoint for these users. So for a week or so, let's just turn up the rate, so that we can catch some of these rare things that are happening. It's nice because it doesn't wake you up in the middle of the night. It's very cost effective, but you have the ability to grab everything when you do really want it or need it.
All right, so I said at the very beginning that this would be a great forum to say, this is what I should have mentioned in my talk. So here you go. What did you neglect to mention in the talk?
I forgot to really emphasize what you're doing is okay if it works for you.
Yeah, sure. I got that in your talk.
I feel like some people didn't. Some people they act a little ashamed or a little like, you're going to be mad at me or this. And I'm like, no, if it's working for you, great. I would never recommend that you rip and replace with something new as long as what you're doing is working.
Some of the things that you talked about was structuring data, make sure you're sending events, things like that. I think those were things that if what you have now is working for you, those are ways to kind of level up and kind of step up to scale.
Well, I feel like it is something that I need to be better about just repeating is, you know what? Do what works for you. I'm just trying to help for the people who do have these categories of problems.
So Charity, we're about to wrap up. Anything you want to leave everybody with?
It's not hard to get started. You can run a great, metrics and dashboard system in conjunction with just using something like Honeycomb for answering questions, like for platforms. We have some customers who just use it for the high cardinality stuff because it's worth it to them just for that, because it saves them so many hours of engineering time in the hopping around from tool to tool just to be able to understand what each user is seeing. And if you start at the edge, then in my experience, generally people will start instrumenting the painful points. And over time, I think it took us about 6 months at Parse to work up to a system that was fully instrumented from end to end. As something became hard or relevant, or we started having questions about a different component, we just get the data in. We kind of lazy loaded everything, but it's not like you have to start out with the goal of doing everything right away or it's not going to be valuable.
Yeah, that's what I wanted to know. What is that end state? Because it seems like there isn't one. It's a continual. It's an evolutionary.
It is. You're never going to be able to stop until you end of life the service.
Yeah, it's like, what's the end of the microservice architecture?
But I feel like there is a reasonable pause point where your engineers have the information that they need to get the job done quickly. They can answer the questions that they have just effortlessly. And that is not every single thing. It's, 20% of the work is 80% of the gains.
All right, so if people want to know more about Honeycomb.io, it's Honeycomb.io.
Yeah, and we have a blog where we've been writing a lot just about instrumentation and, sampling and events, and it's just nerdy and fun and awesome, and you should probably check it out.
Very cool. Charity, thanks for chatting with us.
Thank you for having me.